So let us look at how to obtain the radius of curvature in Cartesian form in today's class. So let us consider the curve y equal to f of x. Now കഴിഞ്ഞ ക്ലാസ്സിൽ ഫിഗർ കണ്ടു y equal to f of x ഇവിടെ tangent that is intersecting the x-axis at an angle psi. So therefore the slope dy by dx is going to be equal to tan psi. So that will be the slope of the tangent. So we will get dy by dx equal to tan psi. Now let us differentiate this equation with respect to x, with respect to s. So differentiating with respect to s on both sides. So we will get, so when you differentiate, so here you will get dy by ds of dy by dx equal to dy by ds of tan psi. So by chain rule of differentiation, this will be d square y by dx square into dx by ds varum. So this is equal to, again using the chain rule here, this is sec square xi into d xi by ds. Now from this equation we will get, so ds by d xi, that will be equal to sec square xi by d square y by dx square into dx by ds varum, and this can be written as ds by d xi equal to, now we have sec square xi can be written as 1 plus tan square xi, so 1 plus tan square xi into 1 by ds by dx I can write as ds by dx, denominator d square y by dx square. So therefore ds by d xi will be equal to 1 plus tan square xi into ds by dx will be, so this is root of 1 plus dy by dx whole square. അതാണ് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പ്രൂവ് ചെയ്തത്. So 1 plus dy by dx whole square വരും by d square y by dx square. So that is ds by d xi will be equal to, this is 1 plus, again this is 1 plus dy by dx whole square. അപ്പോൾ ഇത് രണ്ടും കൂടി tan square xi will be dy by dx whole square. അപ്പോൾ ഇത് രണ്ടും കമ്പൈൻ ചെയ്യുമ്പോൾ you get 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. So that will give us d xi by ds as, so take the reciprocal, so we will get, okay, so we need to find the radius of curvature. It is on radius of curvature. So we have d xi by ds, that will be equal to the curvature. Curvature reciprocal on radius of curvature. So this value will be the value of radius of curvature. So therefore radius of curvature, so rho will be equal to ds by dxi. So that will be 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. So that is the value of the radius of curvature. Let us now look at other formulas for radius of curvature. this is when you have a curve y equal to f of x. Y equal to f of x വരുമ്പോൾ 1 plus dy by dx whole square or 3 by 2 by d square y by dx square. That will be the expression for radius of curvature. Now let us look at the other formulas also. Proofs of these are not required. The radius of curvature evaluate ചെയ്യാനുള്ള problems ആയിരിക്കും നമ്മൾ ചെയ്യുന്നത്. അപ്പോൾ the formulas ഓർത്തിരിക്കുക. So if you have a function in the form x equal to f of xy, so in that case the radius of curvature, so rho will be, so it can be expressed in the form 1 plus dx by dy whole square whole power 3 by 2 by d square x by d y square. And similarly, then you have parametric equation. So when your curve is represented in the parametric form, so let us look at the formula for radius of curvature. So if x is equal to small f of t and y is equal to capital F of t, so we will get rho equal to so that is f dash of t whole square plus capital F dash of t whole square whole power 3 by 2 by f dash of t into f double dash of t minus f dash of t f double dash of t. ഇനി നിങ്ങൾക്ക് ഈ ഫോർമുല കണ്ടുപിടിക്കണമെങ്കിൽ ചെയ്യേണ്ടത് ഇത്രയേ ഉള്ളൂ. നമ്മുടെ ജനറൽ ഫോർമുല dy by dx and d square y by dx square substitute ചെയ്യുക. That will give the respective formulas. dy by dx എന്ന് പറയുന്നത് y is in the form y of t and x is in the form x of t. നമ്മൾ പാരാമെട്രിക് ഇക്വേഷന്റെ ഡെറിവേറ്റീവ്സ് കണ്ടുപിടിക്കാൻ പഠിച്ചിട്ടുണ്ട്. So that is dy by dt by dx by dt. ഇനി അതുപോലെ സെക്കൻഡ് ഡെറിവേറ്റീവ് കണ്ടുപിടിക്കുക. Take dy by dx of dy by dx. So that we have seen how to find out. So once you simplify this, you will get the expression for rho in parametric coordinates. So this is the final expression, and the sign can be positive or negative. Now again, if you have equations in the polar form, so radius of curvature, polar form again, you have curve in the form r equal to f of theta. So we have x equal to r cos theta and y equal to r sin theta. നമ്മുടെ curve r equal to f of theta ആണെങ്കിൽ x ന്റെ വാല്യൂ വരുന്നത് f of theta. So in the polar coordinates, x is r cos theta, y is r sin theta. For the given curve, r is f of theta. X ന്റെ വാല്യൂ f of theta sin theta വരും, and y യുടെ വാല്യൂ f of theta. So again, this is in the നമ്മുടെ parametric form തന്നെ വീണ്ടും എത്തി. അപ്പോൾ x is expressed as a function of theta, y is expressed as a function of theta. Again, evaluate formula കണ്ടുപിടിക്കുന്നത് dy by dx ഉം d square y by dx square കണ്ടുപിടിക്കുക. That will give the required formula in the parametric form. So the formula is going to be this. So that will be r square plus dr by d theta whole square whole power 3 by 2 by d get r square plus 2 dr by d theta whole square minus r into d square r by d theta square. So that is the expression for the radius of curvature. So those are the formulas for radius of curvature in the Cartesian form, parametric form, and the polar form. Look at an example of finding the radius of curvature. So here we have a curve which is given in the parametric form. So we will use the first formula, Cartesian form, in the formula usage. So let us see how to find the value for the radius of curvature. So by definition, rho will be equal to 1 plus dy by dx whole square 3 by 2 by d square y by dx square. So dy by dx will be dy by dt by dx by dt. Dy by dt is a into cos t is minus a into it will get sin t by dx by dt is a 1 plus cos t. So therefore dy by dx will be a will cancel out, so we can write as sin t by 2 cos t by 2 and 1 plus cos t can be written as 2 cos square t by 2. So we will get 2 cancel out, cos cancel out, that will give us tan t by 2. And d square y by dx square will be d by dx of dy by dx. So that is equal to d by dt of dy by dx into dx by dt varum. Sorry, dt by dx varum. It will be d by dt of tan t by 2 into dt by dx is 1 by a 1 plus cos t. So that is 1 by 2 into c square t by 2 1 by a 1 plus cos t will be 2 cos square t by 2 varum. So that is 1 by 4a sec raised to 4 t by 2. So that is the value of the second derivative. So therefore rho will be 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. So we will get 1 plus tan square t by 2 whole power 3 by 2 by 1 by 4a sec raised to 4 t by 2 because c cube t by 2 varum 4a will come to the numerator sec raised to 4 t by 2. So that will be equal to 1 by ct by 2 varum. So that is 4a cos t by 2. So that is the required value of radius of curvature.